Section 4. Algorithms and approaches for vision learning objectives. By the end of this section, learners will be able to 1. Describe the evolution of computer vision approaches, from simple handcrafted rules to deep learning. 2. Explain how early algorithms focused on detecting patterns like edges and shapes. 3. Understand at a high level how convolutional neural networks, CNNs, empowered modern computer vision. 4. Recognize why data is critical to training vision systems. 5. Appreciate the strengths and challenges of different approaches. Now that we know the main tasks of computer vision, classification, detection, segmentation, and tracking, the next question is, how do computers actually perform these tasks? To answer that, let's look at the two eras of computer vision. Early handcrafted methods and modern deep learning. Early computer vision, handcrafted features. Before machine learning became powerful, early computer vision relied on rules and patterns designed by humans. Engineers hand-coded features, small clues in the image that could help identify objects. Edge detection. Algorithms scanned images for sudden changes in brightness, often marking outlines of shapes, corners, and textures. Algorithms looked for repeated patterns, like fabric textures or the square corners of windows. Template matching. Systems compared new images against stored templates, like puzzle pieces. Example. A robot programmed to recognize road lanes might look for straight, bright stripes against a darker background. Strengths. These methods worked reliably for simple controlled tasks, like barcodes, character recognition. Limitations. They struggled when images were complex, messy, or included variations, e.g., recognizing the same face in different lighting. The shift to machine learning. As computing power improved, researchers realized that instead of hand-coding rules, algorithms could learn features directly from data. Instead of telling a machine, an eye looks like this line and circle, you let it study thousands of faces and discover what an eye looks like. This opened the door to more flexible, scalable vision systems. The deep learning revolution. The real breakthrough came with convolutional neural networks, CNNs. At a simple level, a CNN is inspired by how the human visual system works, starting with detecting simple edges, then moving up to shapes, and finally recognizing whole objects. Layer 1 detects edges and colors. Layer 2 combines them into simple shapes, corners, curves. Layer 3 recognizes complex features, eyes, wheels, leaves. Final layers puts it all together to classify or locate the object. Example. A CNN trained on millions of animal photos starts by seeing edges and colors, then gradually learns shapes like ears, fins, or spots, finally identifying images as cat, dog, or fish. This layered approach makes CNNs the backbone of modern computer vision. Data, the fuel of vision. Whether handcrafted or neural, one thing is clear: training data is essential. Early CV needed carefully chosen patterns. CNNs need massive datasets of labeled images, cats, cars, crops, diseases, faces. The more diverse and representative the dataset, the better the system works for people globally. Strengths and challenges of modern CV approaches. Strengths. Extremely powerful. Can handle complex tasks like face recognition, real-time object detection, and medical diagnosis. Challenges. Require huge amounts of data and computing resources. Can act like black boxes, accurate but hard to interpret. Risk of bias. If training data is not diverse, is she failing on certain skin tones or cultural clothing? Global context medical imaging in Africa and Asia. CNNs analyze X-rays where doctors are scarce. Agriculture worldwide. Vision drones use CNNs to spot crop diseases early. Security and identity. Biometric systems unlock phones or verify passports. Local challenges. A system trained in Europe may struggle in rural India if crops, lighting, or appearances differ. This highlights why diverse global datasets are so important. Reflection. Imagine you are designing a vision system for farmers in a developing country to detect crop diseases. Would handcrafted rules like look for yellow spots be enough? Or would you use modern deep learning? What kind of images would you need to collect? How might bias appear if you only train on certain types of farms or crops? Key takeaways are to 1. Early vision systems relied on human-crafted features, edges, shapes, textures. 2. Modern systems use machine learning, especially convolutional neural networks, CNNs, to learn features from data automatically. 3. CNNs process images in layers, edges, shapes, features, full objects. 4. Data diversity is critical. Without it, vision systems risk bias or poor performance across cultures and contexts. 5. Modern CV is powerful but resource-heavy and requires ethical care to avoid unfair outcomes.